Hello, hello. How's everybody doing today? Happy Friday. Today we are switching it up a little bit. I've got a kind of a queue of potential like small electronics projects that I think would be fun to do on stream. But some of it with the thing with small electronics is a lot of it isn't like just straight out of the box. You can buy stuff that's just like drop in and do the thing. But some of them are more developer geared, and it takes some understanding or building up a knowledge base to like jump into it. So I've got a couple potential projects that I want to work on stream, but some of them will take a little bit of prep work. Part of it is like figuring out what I need and what like small devices I need to connect together to get things to work. And that also means then procuring them if I find out that I need something that I don't have. So today we are going to be looking at, I think actually in my thumbnail I got it upside down, but we'll be looking at this today. I guess it's the camera down here is flip-flopped. This board is a small sensor development board, I guess you would call it. And the idea is that you hook it up to another board through the little holes. There's a little like there's pins. It's got has a piece of felt that the pins are through to make sure the pins don't get bent. Might be able to see it on the. Ooh, let's go this way. Those pins right there, they go through the board. They hook into other boards. GPIO headers, I believe, would be the term for it. And there's a couple of different sensors that this board has. It was actually a Kickstarter project that I backed last year sometime. And the idea is that you plug it into like a Raspberry Pi of some sort, and you can pull a bunch of the sensor data off of it. So you could have these like small little sensor boards that you can have. I'll probably just put them in my house because they'll measure like indoor air quality and that kind of stuff. So I need to figure out how to hook it up. I have the board. I have a couple of Raspberry Pis that have some are in use, some are in less use, I guess. And we need to make sure, or we need to figure out and understand how to like put these things together. Then we can start actually playing around with the software, the code to interact with these with the sensors on it. So that's kind of what we're going to do today. Basically do a little bit of legwork, look into what this board is about, what features it has. I'm not sure if you can get them. I know he did a big Kickstarter and a big like shipment of them. I don't know if you still can get them though. We can take a look though. They were interesting because they had a whole bunch of sensors on it and they weren't particularly pricey, and they were small to where we could plug them into very small, like a Raspberry Pi Pico, I think they even work with. So the power draw is very minimal, and you can have them potentially just run off of a battery in like remote parts of your house, or some of the displays or demos that they had were like attached to a tree outside. So yeah, well, we're gonna figure it out. Make sure I've got everything. Understand what we all need to make the thing work. And make sure I don't have to buy anything else to get to the point where we can get to the like software side of it. We'll flip over here. I do use Obsidian. I did a couple of Obsidian streams a long time ago. I am not the best note taker, but when I do take notes, I pretty much put it all in Obsidian. And this little tag here, long story short, makes it go to my website. So when we'll jot down a whole bunch of notes, and when the stream is done, I'll drop my notes, or my notes will be there, and I'll make sure they get published. So they end up showing up like on my website. So they'll be, I think they'll probably show up under articles. So it'll probably end up showing up in here somewhere. And then this little seedling thing designates that progress is still in growth. As in, it is very much a node, and I'm expecting it to evolve, and it hasn't like hit the point where I feel like it makes sense as an article. Like this one is a little bit more detailed and thought out and kind of reads well, whereas these are more, I think this is just a whole bunch of links. Yeah. So we'll have some notes afterwards, but up until that point, we'll just jot stuff down here and kind of figure out what we're doing. I still have my hopefully the stream overlay works now. I don't know if bot messages show up. Please? I was hoping that I had fixed that. If not, then, you know, it is what it is. Really? We're gonna take a brief distraction, and I just want to see. Here. Why would it not be working? I've got like multiple projects that are still like in progress, and I need to just. But part of the reason I wanted to just do a little bit of or do a research hour here was to change the focus a little bit, mix things up a little bit, but also there's a bunch of projects that we've done on stream now that I actually need to throw up a bunch of commits and kind of close those out, and I just haven't got around to it. So it doesn't make sense to push them forward. What the heck? Not one password. Oh, not F4. What is my hotkey? X. Did chat events change? Oh. Chat message, okay. Statistics update. I'm actually kind of curious. I feel like I've looked at that before and mentioned that I was curious. Huh. Well, I guess it's not that big of a deal. Well, I still got some more OBS work to do, I guess. The button's labeled wrong. That's what I was trying to do before with the drop. There we go. Yeah, I don't know. More things to deal with. But we did a whole bunch of that stuff on stream. A lot of it in like the end of December and into January, I guess, a little bit. Putting everything into WebGL scene. So the chat's all hooked up with physics and everything. I just need to finish up the little bit of wiring, and we were working on highlighting messages. And ever since we started poking on that, I broke things a little bit. I haven't been able to like get back around to fixing it. But we do still want to be able to highlight messages. I think I'm just gonna, rather than having them pull out of here and highlight, I'm just gonna drop them down from above. It'll keep things a little bit simpler. And then deleting messages too, spam and those types of comments. There's not a good, so what shows up down here, that also has like a filter on top of it, and what I get here, I think it's just like a raw stream of events. So if this filters out spam, it still ends up showing in here, which is a little bit weird. I wish, I don't know if that's just an API difference thing or what, but it would at the very least we need to be able to delete messages, because even if this doesn't catch it, like pre-filter it, I still need to be able to delete it up there. Even if it gets filtered out there, I still need it filtered out up here, but also everything isn't going to be filtered out properly here. So I got things to do. We'll clean it up. I'm not going to worry about it today though. We want to look at this board. So we are going to go pretty much full screen here. So this is, we've got a little pinout card. Again, it's backwards, which is kind of annoying. The other thing, maybe having this camera flip-flopped isn't a big deal, because I got this a while ago. It's very reflective because of the plastic. I want to do a better top-down camera, and I think that's going to help with the small electronic stuff, but also I can make sure it's not reversed, because that's sort of annoying. So we got some things to set up, and none of it actually makes sense to do on the stream. I might actually do some like unboxings of stuff, and some of this, like figuring out the small electronics. I might do those in like little shorts or something. Let me know in the comments if that's something that you'd be interested in seeing. I do actually have an old, now that I'm completely distracted, I do have an old computer prior to the one that I'm streaming on right now that's like a quad core or core duo. I don't remember. But it's got like a, I don't know, 480 GPU in it or something. It's a little bit up there in age, but I been getting a little bit more into like home lab type stuff. I don't need a whole ton of compute, just something to run little things on. You know, like these Raspberry Pis have been nice for this. But I did. Got a little bit of thermal paste. Because the thing that I sort of killed that, I don't think it actually killed it. It just sort of rendered it unusable, and I didn't have the space or time or interest in dealing with it. I had an AIO, all-in-one cooler, like a liquid cooling loop that plugged in to the CPU and went to fans to cool the CPU. And that broke and started leaking. So then I had to switch to the stock cooler. That was still back when CPUs came with stock coolers. And I just didn't bother repasting it or anything like that. I just tossed it on there because I just needed to get it along a little bit further. And then I sort of put that one aside once I got this computer soon thereafter. So I kind of would like that to be like a little server, and I'll probably just stash it in the basement. But if I can get it working, and if it still does work, it's definitely going to need repasting. So, you know, $5 or whatever it was on paste was worth it to see if the thing still works, and I can run it as a little server on the side. So, anyways, this. So it's got a bunch of pins that are labeled, and I have no idea what any of them are. Actually, they have a Discord too. I don't remember if I joined it. I mean, at this, I kind of, for a while, didn't join too many Discords just because it's hard to keep track of them all. But at some point the dam broke and it was just too hard to care. So I've got a whole ton now. And I don't participate in nearly all of them, but it's nice to at least get announcements and stuff from some of them. Yeah, so here, this is what I was talking about. They have, this looks like a Pi Pico. I think that's their custom app. It also has a gesture sensor. So I think there's some fun things that we can do with it. I've got a little e-ink display that I can't really pick up because it's plugged in. That I've got hooked into a Raspberry Pi Zero. I kind of would like to, I got two of them actually. I got two of these sensors, one's still in the bag. I would like to have one at my desk plugged into that, if I can. And it doesn't seem like it takes too many pins, so it might still work. But on top of that, I also want to put one like on the other side of the house, do kind of an air quality sort of thing, but also the ability to like do gestures and waves and stuff would be kind of fun. So we've got a air quality, sound, light, temperature, proximity. I think when we get into a little bit more of the like home lab type things, I do want to potentially run a home automation server. Probably the big one, and the one that I will likely end up going with is I can't think of it now. What is it called? Home Assistant. It is Python based. And it's pretty well supported. A lot of it is done via YAML documentation and config, which isn't not a huge fan of. But it's got a lot of support. There's a lot of people working on it. Community of tinkerers and DIY enthusiasts. So I think like this has the customizability that I would want if I'm running something like this, and I think I can then pipe this kind of stuff into it and some of the other home automation stuff. I also have a bunch of like Wise lights, and I think we have a Nest thermostat and stuff, so it would be cool to kind of connect some of these things together. I'm not gonna watch the video, I've watched it already, but this is kind of a overview of like what's actually in it. You can, it doesn't actually need to draw. I don't think you have to use this battery holder. I think you can get the power from the board that it's connected to. So depending on how we want to do it, I think we have options. And these are the different sensors, of which they explain what each is down here. Some of these I know, some of these I don't know what they are. But these are like the controllers, and you can buy these. This board is kind of a combination of a bunch of like off-the-shelf sensors, I guess. So if you are tinkering with other boards that have sensors, some of these might be familiar. But like we've got a quartz crystal that gives us timings. We have temperature, humidity, and barometric pressure. And this is kind of nifty. It can output IAQ, VOC, and CO2. So IAQ would be indoor air quality. VOC would be volatile organic chemicals. Yeah. And then CO2 would be like the part of the air that you breathe out, CO2. At least I'm pretty sure. Pretty sure that's what that is. So like these would be pretty much all of these are something that I would just be interested in having, you know, 1 or 2 locations in the house. Grab this that are not right next to my thermostat and use those as potential input into controlling some of the other home automation stuff. This sensor I think would be fun at my desk. I'm not sure how that's going to work as far as integration goes. If I'm hooking this up to the same Raspberry Pi that has my display, I might have to have it like connected in just like a separate piece or something like that if I want to do these type of gestures. But to be able to like turn lights on and off, or you know, just have the screen update, like trigger a like manual screen update would be nice. Sound levels, I don't know that that's really going to be too useful for anything that I want to do. And then I2C sensors, I'm not sure what those are. I've heard those before and I've seen them on electronic things, but I don't know really what they would be for. I don't know if that's like a connection to other boards that would have additional sensors. So like this, then this is actually kind of cool too. I didn't think about this, but reading Room Too Dark actually made me think about it. We can detect light, so we could do things like if my lights are turned off, I can, you know, like not have the e-ink display update or something like that. I don't think do any of this. This is kind of fun. I don't think I'm gonna find that useful because just general, you know, like if I'm on stream or whatever and I'm just talking, I don't want that triggering, you know, having my lights flicker on and off. This is actually kind of cool. I wouldn't trust this because it's next to water, but I think we can use gesture sensing. So they do have support for. Is there anything else here? I don't think there's really any other links that we can go to. Yeah, so this was a year or 2 ago. So pretty young person. And this is a neat thing. I was like, I will throw my support at that. So they've got a bunch of stuff on GitHub, and I got this probably actually around the last time this was updated. And with a lot of these like Kickstarter new projects, you can jump right in and kind of be the one to run into the issues and find the bugs. But between holidays and everything, and not wanting to be the one that has to do all the debugging, I kind of set it aside for a little bit. Oh, this is kind of cool. They got some more on here. Control the, yeah, so like this is probably something that I want to look at doing through Home Assistant. Plant monitoring system. So the other thing would be, this was pretty much just through Kickstarter, and I don't know if there's another way to actually purchase these now. I think they have done this primarily through Kickstarter. So like in the projects, you can see that they're sort of just like wiring these two things together. Oh, there's a cord. Remember I was saying I don't know what this quick connector is for? I wonder if that's a way that you can connect it to boards. So let's, there's the user guide here. Good old PDF. We'll likely use a Raspberry Pi just because I have some available. But there's other things here. They all, the reason that there's this compatibility, you could probably get it working with other things, is somewhere in here they've got, yeah, Raspberry Pi library and an Arduino library. So this is C++. I think this is Python. Oh, here's a Python lib. So, okay. So this is the other thing, that they're using these sensors that are sort of like off the shelf from Adafruit, which means that we don't necessarily have to rely on this person, the board maker, to be the one that's putting all this code together. We can kind of build off of the work that Adafruit has also done. And I've got that e-ink display that I have. I believe that's from Adafruit. So they definitely do good work. Board files. Huh, that's kind of cool. So I think you could potentially get this to work with other things, presuming that this is really bright. Because these are all sensors that are built from Adafruit, I think, and he's pretty much done like the board creation and the soldering work to get it all to work together. We do need to make sure that we're only using 3.3 volt. It's good to know. And what else do we got in here? So this we kind of went through. This is the pinout that's on this card. This card that I was holding up before, same pinout. Except it's not switched here. Oh, there's two. So we have two I2C. Is that actually on this picture too? Oh yeah, quick connector. Okay, so we got two of those. I don't know what we would actually use that for, but that's good to know. Oh, wait. So the wiring is the same. There are three sensors that use the I2C. The microphone uses PDM, and the micro SD card holder that uses SPI or SDIO. I guess the QIIC or quick connector is something special. Those are all letters that I don't know. So here's some like connecting diagrams. So we would do, this is a like full-size Raspberry Pi. I don't know if we can. Okay, so this is to get where we can 3-volt power, and GND is ground. So I think for the most part we only need those connectors here. Let's open up. I've got the Raspberry Pi 0 W. It's not the 2, it's just the old one. What? Do we have a diagram or something here? I do have a header in there, which we needed for... That's not really what I need. Documentation. Here. So I don't want the Pico. Oh, they use Algolia too. Raspberry Pi. Compute module hardware, Raspberry Pi. I guess this is probably what I want. So this is for the full-size one. Do they have... Alright, here we go. Perfect. So this is a Raspberry Pi 0, which is what I have connected. This whole like string of holes here is what I have a header pushed through, and that's how the e-ink display is connected to all of those. I don't know if I can like connect onto the top of those though. So the question I would have is what kind of, maybe we can actually see down here a little bit better. So like this is a Pico, and that's got this, what I believe is the I2C connector to it. It doesn't look like we have one of those on the 0. So I think this is HDMI, SD, USB. You can kind of see some of these are labeled too. GPIO headers. Yeah, I'm pretty sure that's HDMI. This would just be like normal USB, like you can hook up a keyboard or something to it. And then this one right here is the I think strictly just a power. I don't think I have anything else wired up. I don't know what this thing at the end is. So if we look here. Oh. Alright, okay. So test pad locations. Blah blah blah. Schematics maybe? Oh, I'm looking at the 2. Where are they? Oh, okay, so electronic diagrams. This is CAD. Looks a bit like some AutoCAD. So we got a bunch of like information about the pins and stuff. Here's GPIO is those like all those lines of circles. So this is at boot time, the I2C interface will be interrogated to look for an EEPROM. So it has something with I2C on there. This looks like HDMI. That's about it that I can kind of gather from this. My electronics background is not terribly deep, so and this is strictly just like sizing and stuff. So like I kind of understand some of this. I enjoy looking and playing around with electronics, but I'm not a big fan. I mean, it doesn't. Learning electric and circuits and stuff doesn't really interest me. I just like using them. So like laying this stuff out and figuring it out and like this type of diagrams, not my thing. Perfectly happy letting somebody else handle that for me. So like I've had classes and done things with circuits, so I kind of understand what some of this is, but that's as far as we're gonna go. So we have HDMI, camera attachments. We got a bunch of GPIO, and then we've got some stuff like this where I don't know what DNI means. SPI. So it might not be, we might not actually be able to use this Raspberry Pi Zero. And that's okay. If we have to, I have two of these boards again. If I'm planning on putting them in places, I don't necessarily need to have everything connected to the same Raspberry Pi board. I'm perfectly fine handling some of this via like networking. I've got Tailscale hooked up or set up in my network. Yeah, well, I guess it's not really a network, but Tailscale. Pretty nifty. If you haven't heard of this and you're at all interested in like networking computers together, pretty cool. So what it ends up doing is basically allows you to install this program and allows you to essentially like set up a VPN for all the devices that are connected to it. So I can SSH into my Raspberry Pi theoretically from anywhere. I don't have to actually be in the same network. The same like I don't have to be in the same switch or Wi-Fi. I can, be at my mother-in-law's house, and as long as I can have a thing that connects to the Tailscale network, my phone for instance, I can toggle on the Tailscale VPN, and now I'm connected to basically all my other devices that are already connected to this. So I can SSH into my Raspberry Pi via my phone, which is pretty sweet. And I don't have to worry about the exposure that comes from like exposing this at a reasonable DNS and opening up a port, making sure I lock all that down so other people can't get to it. I can just handle it all through this. So I can kind of have the connectivity that I want in my like small network of devices and the access through this, which is really nifty. So if we have to, we can throw these things on their own like kind of disparate devices and do something like they show in here, where you have just a Pico that's connected to this board. I don't know what that other little board is there, but like they've got a Pico. It looks like a Pico connected to some power somehow. I'm guessing that's power, and then that looks like a little sensor or a little additional connector that's just hitting a couple of those pins on the Pico and going there. So it seems like that's sort of going to be the way that we'll probably end up wanting to connect to it. And this is the other thing that we need to figure out here. This is clearly connected through here. This is connected through here. We may have to have different connections for different uses of each of these sensors. So like this is, as I understand it, more of a board with all of these sensors. That doesn't necessarily mean that it's like has its own shared interface or microcontroller, I guess, to where you connect to the board and you have access to all the sensors. I think you need to connect to each sensor via basically like these inputs. So like we would use a quick connector to connect to some of the stuff. And I think if we look on here, I think that's sort of the like I2C, we get a connection to these. So like green goes to the mics. So if we want to hook up to the mic, we would have to use these. And okay, yeah. So if we want to do anything with the mic, which I don't really care about, that's PDM. I don't really care about necessarily using the micro SD card. I'm perfectly fine like piping that back somehow. So it looks actually like all the things that we care about. Time, proximity, gestures, and the temperature sensors, and IAQ and everything. Oh, using the Bosch BSEC library. So Arduino only. So it could be we might get raw values out of here. And with this library, it might be doing some conversion for us. So I'm not going to completely write off Raspberry Pi as not being able to do this at the moment. We'll have to come back to it and think about it. But I think as far as interfaces go, I2C is going to give us everything we need to all of the connectors. So if we make a connection, oh, look at all these connecting diagrams here. So we have an Arduino, we have a Adafruit Feather. Oh, I wonder if some of those Adafruit Feather, or some of these pictures here is actually not a Pico like I was guessing. That might be. This is definitely a Pico because I can see like a little raspberry symbol here. That. Oh, where'd it go now? Sensor here. So the feather. So the Adafruit has that little like flower type symbol on it. And it doesn't have a connector at the bottom here, just on one side. This has two, so I think those are Picos. I think those are Picos. So this would be a Raspberry Pi. More pages. So like this, once we get everything connected and it's working, then we can start getting into the basically this part of it where we're using, it looks like we'll end up using each sensor. That's the word. I don't think these are technically microcontrollers. Fuzzy on the terminology there. But once we get everything hooked up, then we can start to use the Python libraries. Primarily, it looks like from Adafruit, because these are all Adafruit things. Let's actually look real quick. Adafruit feather. I don't really know what's in these. And some of this too is so some of these are the ESP. Yes, so like this is an ESP. I have a preference, I guess you would say, to Rust. It would be kind of fun to do some of this stuff in Rust. And there's some Rust embedded stuff that works with ESP. TBD on how we all end up wiring all this together, both on the software and hardware side, but I kind of wouldn't mind playing around with some Rust. It would be fun to do some of the Rust to deal with that. Interesting. That is very interesting. I do actually have for cooking, I've got a instantaneous thermometer. So like you stick it in, you know, eat your casseroles or whatever, and it gives you your temperature reading. So you make sure to cook it to the appropriate temperature. It seems like we might need some burn-in or calibration to set these things up. We've got ways to do that. It looks like, so we've got a Raspberry Pi, ESP, and Arduino. Adafruit Feather. I don't really care about the PDM, right? Because the PDM is for the microphone. So I don't really care about that. Like we could potentially do a thing where we like trigger the lights or something like that if you clap. So like a very high decibel would basically like turn off the lights or turn on the lights. But also I have kids, so that's not entirely practical. Just checking to see. I thought I saw a notification. So I think we're mostly going to be sticking with this I2C, whatever that stands for. I don't really want to deal with a board like this. So these are like development boards where you this whole board here has wiring in it. So you stick the little pins into the holes, and then it allows you to make connections just with wires to each of these like little pins. I mean, that's fine for just like getting it set up and playing around with it, but it's not practical as far as like, I want to be able to do like something like this. But also, I'm not sure how these sensors work as far as like, this is an enclosed box. Does that mean that our air quality and temperature settings are gonna kind of be funky? This is probably fine for like barometric pressure, I would imagine, but I don't know how it actually affects the temperature setting or temperature settings. Wow. But I don't really need an enclosed thing. I can probably keep it mostly open air, especially if we're planning to use the gestures. So like this right here, this has got another piece here. I have no idea what that is. So it might very well mean there is a Discord link on here, presuming it is still current. I might end up jumping on there and dropping a couple questions here and there. Because it seems like all we'll want to do is, I think we can just hook up via this I2C connector. So then it's a matter of what Raspberry Pis have this I2C, and what's going to be like the easiest way to do that. I don't. So we've got a potential subset of ways to hook up to this. I don't know what the Raspberry Pis have. It seems like the Feathers also have some options. And some of these have like the Bluetooth Low Energy, built-in USB and battery charging. I don't know if I really want to deal with batteries, to be honest. I mean, if it's one of those situations where it's like I can monitor the battery and they last like 6 months or a year, 9 months. If we're pushing up to like 9 months or a year, I would think I'd be fine doing a battery. I mean, the one at my desk I probably could just plug right in, but the one on the other side of the house probably would be actually more convenient as a battery. And like so this is sort of like the pins that we used for the Pi Zero, where I stuck the pins through the board. Actually, it was like a sandwich. I hammered. It's called like a hammer header or something like that. Through the Pico, and then I put the e-ink display on top of that. But we could potentially use one of these feather boards, but I don't know anything about the. I don't know anything about these feather boards, so we would have to do more research into those to figure out like what's the options there. What is the So all of the pictures show a Pico. Let's look at the Pico and see if the Pico actually mentions anything about I2C. Dual core, wireless LAN, USB. I2C. A wide range of flexible I/O options include I2C, SPI, and PIO. PI0 maybe? So this does mention I2C. This doesn't seem to. What about the big boards? The Pi 4s. Do those, not saying that I actually want to get one of those, but does this mention I2C? No. So I don't think it necessarily means that if it's not mentioning it, that we don't have the option to do it. But it might mean that we have to do something special with the pins. So there's this 40 pin header, and that I think potentially has those I2C pins based off of this. So what is this? Test pad locations. We have the schematic drawings. So ID and ID SD and ID SC pins. These pins are reserved for ID EEPROM. At boot time, this I2C, so this is an I2C interface. Okay, but that doesn't necessarily mean that's like a connection that we can use. Let's see what I2C has, just as far as searching for it. Open source tool for controlling I2C devices over USB. Interesting. So that's a potential option. We could have it as a like USB input. Okay, that's got a lot of like technical terms in there. A rotary encoder, that's kind of cool. So like you can see that some of these MPL like these little controllers right here, are they controllers? Microcontroller. Add another 16 pins to your microcontroller using the port expander. I think these basically are like pieced together. That's how they work with the other thing. So, I mean, we might be able to use something like this where we have a board, in our case, the Sense, has these I2Cs. Come on, focus. I can see that working, where we could then use this a little board like this to hook up to USB on the like Pi 0. But also it seems like the Pico just has a direct connection. And I think I might have a Pico in the basement. So this right here is USB. It looks like on these they're not actually using the USB though. Assuming that is actually a Pico, like I'm kind of getting the feeling from. So this doesn't actually have any power here. It doesn't look like there's any pins that are going to the power. It seems like it's just this one that is going to the top right, which I believe would then be basically like these top couple pins here. So like power and ground maybe. So which ones are the I2C pins? There we go, here's a pinout. I2C and I2C default. I'm not quite sure what the difference is between those, but so like these top couple pins are all I2C, and we've got some like STA, SCL, those kind of things. So something like that might be the type of connection that we want. Because I think these same sets of pins are also matched on the Pi 0. So like this same line of headers is the same line of headers on the Pi 0 here. So like we might be able to use those pins as well. I'm not sure if the e-ink display has that though. So we'll have to figure that out. What else do we have in this I2C? So a bunch of these are just like forward controlling I2C devices. It's interesting that it's like been a while since I did math, apparently. Not a subscript, superscript. There's a lot of devices and stuff in here. So if we look at I mean, maybe kind of like breakout boards. So the Raspberry Pi have it with it. So these are all like the RP2040. So honestly, I have no idea what that's doing. Here's a bunch of these sensors, so like the barometric and whatnot. What do they have these connected to? We got some YouTube links. They've got a bunch of them hooked up through dev boards. Interesting. So this has, it looks like those couple pins here. It has a Stemma QT connector for I2C devices. So that might actually be what we're seeing in the picture. It's a, I don't know if that's a feather, but what's this Stemma QT connector? And so the other thing is, so a bunch of these are like, they've got the connectors here. So like if we would do something like this, these could potentially go into those 4 pins and then over to the other one. Hey Ryan, good to see you. That might actually be potentially possible. I don't, so some of this too is like, the board that we've got, is that actually Adafruit? Wow, what is that called? E-ink compression. E-ink compression. We are trying to figure out how we can hook this little board up to any. It might end up being that I need to purchase other small boards like carrier hookup boards or whatever you call them to get this thing to work. But we've got a couple of these little sensor boards that I want to hook up and pull information off of and potentially hook it into like Home Assistant, which would be another thing that we would set up. So we're kind of just doing the research to figure out how to like hook all this stuff together, because I don't know the terms well enough to just know offhand. So this is sort of like the not soldered mechanical connection that I've got set up. I've got the e-ink impression, cranky impression. Oh, it's not from Adafruit, it's from Pymaroni. I haven't actually said that out loud. So I got that hooked up to a Raspberry Pi 0W. So not the 2, but the wireless version of it still. And I'm curious if I can also hook this up to the same thing. I'm using all the pins, so I don't know if I'm actually going to be able to. But, so I don't know if something like this is going to work. I don't think it is going to, because I don't have pins to hook up to. Because all of those pins are taken. So I'm not going to be able to use where are we? Here we go. 0. we've got USB, we've got all these pins taken up. It's not HDMI. I think that's SD card reader. I'm not sure what this thing on the end is. Some sort of ribbon. Can we find anything? No, that's not really helpful. I want a data sheet. High Pico. Okay. Yep, I believe you that you're well documented, but I want the actual documentation. I think it would be under the compute modules. No. So if we go here, software, I need the hardware. Okay, all right. Schematics and mechanical drawings. And I think this is like probably the big thing with. I think this is the big thing with just small electronics in general. You can buy a lot of small electronics. You can buy these small pieces and like solder them together, or wire them up depending on what you're getting. Like the options are there. It's the documentation and the software that isn't, and that's what really like pushed Raspberry Pi forward. I think that support. Like enabling people to actually use the boards that you're selling, I think is really what has pushed Raspberry Pi forward. And I'm excited to see other options out there as well sort of reach this point. So this is all under configuration. So the pinout, so we can get pinouts directly from interactive pinout diagram. Here we go. So we want so it seems like okay, so GPIO is general purpose IO. Integrated circuit. I squared, so double IIC, integrated circuit. Pulse code modulation. And we're using the 3.3 volt power for the sense board. And I don't think we really have any UART on ours. So you can see they're all shared. There's the A+ boards, there's the B+ boards, and the zeros. So they all have the same same pinout diagram, which is also kind of handy. Network, NVMe, HTTP. So if all the pins are taken, I think my only option to connect over I2C would be to use one of the USBs. So I suspect we're probably looking at something like this, where we can connect to like a sense board, I2C to I2C to USB to the Raspberry Pi Zero. So it's another thing that we're gonna buy and wait for. So it might make sense in my case to hook one of these up via USB to the Raspberry Pi Zero, so I have a board that's connected to both this sensor board and an e-ink display, and that'll be like one configuration. And then the other board, I'm thinking maybe something like a. We'll go on their where is it here? PDF. They say that they support Raspberry Pi, Arduino, and CircuitPython. And they've got the Arduino board, and they also have the Adafruit Feather, an ESP32, and the Raspberry Pi wiring. So we're not going to be able to wire it up this way, I don't think. So I think we're going to have to use that little board to make a USB connection, which is fine. And this is going to be the only thing. So there's this BSEC Arduino library. Gives us extra stuff. And unfortunately I can't click on that, which is annoying. I'm going to just drop it on the side here so I can take a quick peek at that. Because that's going to be the only other thing that... Oh my goodness. github.com/Bosch sensor tech /BSEC Arduino library. Bosch Sensor Tech Environmental Cluster. So it helps with calculations. And we've got options for binaries. So there's a Raspberry Pi 0. So we may be able to get it to work if we use this binary. This may be a newer thing. So like at the time of this writing this, it might have only been available for Arduino, but it looks like it does support Raspberry Pi 0. So I think I'm gonna tentatively say that we probably need something like this to be able to hook it up to USB. And then the other one we'll figure out at another point in time. Probably a smaller board. And as I figure out how the gestures and stuff work with this one and the sensors work, I want to say it would be fun to do something like a little feather board or one of these like ESP something boards, hook it up with Rust wherever that went. Here. Play around with this kind of stuff. Okay. So there's a bunch of these like Rust embedded things. And depending on how these sensors work, I might end up wanting to do one of these like ESP boards or something like that. Play around with some Rust. My wife has done a bunch of stuff with the resin. I think it would be cool to do a combination of like all this stuff. A little bit of Rust, one of these like small boards, this sensor board, depending on how it works, and drop a bunch of it in like resin. And depending on how the power works out with these and like the lights, basically have like a little resin thing that is temperature sensor, gestures, little LEDs. I think a lot of that would be really nifty. But that's pretty far off. We're gonna get this sensor board working with this Raspberry Pi 0, I think. And I think this is gonna be our ticket. So I think that being said, I don't know that there's gonna be too much more that we can do today. I'll probably hop on their Discord, assuming this link still works, and just confirm that this is sort of our ticket to getting it to work. And I think we'll go from there. If that's the case, we'll have to, whatever we need to purchase, we'll have to wait for it to come in. Until we do another stream that takes this further. And in the meantime, I'm gonna get that top-down camera working. I also got one of these that are queued up and they've started shipping them. This is also a Kickstarter project. They've started shipping them, but it's pretty much impossible to get CM4 modules, and I'm not keen on actually using CM4 modules with it anyways. But it does support some risk-free rock chips that the Turing team is working on. And I think tentatively the thought is Q2. So this might be like assuming I can get my hands on some of those, this might be like a summer project to stand this up. And then I think this will be the thing that ends up running Home Assistant. Depending on if I've got a little Synology server, NAS, a Synology NAS that's pretty old at this point. Synology 1512 Plus. We may end up standing it up on this first. It's like 10 years old at this point. Yeah, December 2nd, 2012 is when they announced it, looks like. And it's only got a megabyte of RAM, or a gigabit of RAM. And I've tried one chip. Problem with this is the RAM chips are really old, so it's hard to get them. I tried this one, no bueno. I've got another one coming in the mail, hopefully next week, that adds another 2 gigabits. And I might be able to actually support Home Assistant on it. And if we can get Home Assistant rolling, however, the Turing Pyre via this, then we'll have a target for making use of the data that we're actually getting out of the sensor. So, got a bunch of projects. None of them are gonna be happening immediately or fast, but I think we'll occasionally do streams that will drop into this and check stuff out. And we do need to come back to this, I think, and see where I've gotten with it so far. We did a little bit on stream, and I ended up swapping a bunch of it out to switch over to N8N, because this actually has an image magic library. We'll see how long that sticks around, but for right now it actually gives me something usable, a usable readout that makes it useful, so it's not just sitting on my desk not doing anything, because we still had a lot of work to get to piping data in and doing it all through JavaScript, mostly because we need pictures, and JavaScript to pictures is kind of a pain, especially when you're going through small hardware. Both processing power and like C support. The node support on these isn't great. So yeah, I think that's where we're gonna end it today, though. Well, I'll double check to see if this I2C thing is what we actually do need. And I was gonna write stuff down in my notes, but I didn't. Talking the whole time. We'll figure that out. I'll push up my notes there. We'll get something rolling and potentially purchase this board that I need, if that's the way we need to go. And I think we'll stream this again next time we're set up with the boards and the pieces that I need to actually like get it hooked up, and we'll see if we can get some readings. And I should have the top-down camera set up by the time we get around to that. I do have an older camera. I think I took it in the basement, actually. But I was having trouble focusing. And this other camera, I think, is going to be real nice, and it'll work well with future computer upgrades, too. But anyways, those are future streams. So thanks for stopping by, everybody. If you want to see more of the small electronics stuff, if you have suggestions or clarifications on what I sort of figured out today, feel free to leave some comments. Would love to read and learn more about this. It's definitely a rabbit hole, especially if we get into Rust embedded. I think that'll be fun, but it's not going to be a small project by any means. This is going to be probably a year too long process. It'll be nice to break up the streams a little bit. It's the stream content. But anyways, have a good weekend. See you next time. Hit that follow button, and I will see you next week Friday, presuming I don't change the schedule. I know we've talked about that a little bit, but haven't pulled the gun on any of that. But anyways, keep experimenting. Bye.